Hello and welcome to another tutorial from my channel Decode, and my name is Mohammed Asif and I have a lot of experience in software development and I want to share some experience with you. So let us begin our tutorial for today. It is about integers and using the mod operator with integers. Actually it is about the mod operator, and we will apply the mod operator to integers. The mod operator is also called modulus or modulo, and let us see how we can use it. So let us initialize a variable n with 2 and another variable n with 3, m actually with 3, and then another variable like this with 4. And now let us print out the results of the mod operator applied to these different variables. So let us do m mod n, and also let us do p mod n. So what will it return? Let us run it, and you can see it has returned 1 and 0. So what happened here? We divided 3 by 2 and the remainder is actually 1, so it is printed here. This modulo operator actually gives us the remainder of a division operation. And similarly, when we have divided 4 by 2, it is actually completely divisible by 2, so we did not get any remainder and the result is 0. So, and what are useful cases for getting for using the modulo operator? We can actually generate a series of even numbers, and how we will use and do that? We will actually have a loop here, and we will initialize it with I equal to 0, I is less than 20 for example, or let us take as 10, and then I plus plus. So, and then we will check whether I mod 2, any number that is divisible by 2 is an even number. So, and then we take this the result in a boolean variable. It returns, this is a boolean expression. Actually this is not a boolean expression. We will actually equate it to 0, whether this is 0 or not. Whether this is 0 or not, we will then assign it back to a variable of boolean type is even, and like this. So what will it do? It will tell us that the current loop variable is actually an even number. So we will write it down here like I is an even number. I is, like, we can actually do it like this: I plus is even, and we will put it in a if block, that if is even equal to true, then we will write it, and like this. And this is just so that you understand it properly, that what is going on. Otherwise we can actually skip this comparison. We can just have it is even as well, because the whole expression is actually passed to the if block. This if condition, the whole expression result is passed to it. So the if we can use a variable, or we can use an expression like this. And if we need to, for example, we want to check like 2 equal to some number 3, then we can do it like this in variables. Actually these are literals, but if we have a boolean variable we can just use it. So if is even, then we can print it like this, and then we can actually, if it is not even, then it is odd, so we can print out that as well. It's like this: I plus is odd, and we actually start it with 1. So this is how we can find out even and odd numbers. And we can see that this sysout print even and odd, so we can have it. And this is 1 is odd, 2 is even, 3 is odd, 4 is even, like this. So this is a useful case. Then if we want to actually check whether a number in the series is multiple of 5, then we can do that as well. For example, and how we will do that, we will have a loop here, a loop just like this same loop, and what we will do, we will use I percentage sign and then 5, and if it is equal to 0, then it means is multiple of 5, and then we can print it out. If is multiple of 5, we can print it out like sysout, and this is like just print the loop variable here, so we get it like this. 5 and 10 are multiple of 5, and we can actually take it to 50, then we can get the multiples of 5 up to 55, 10, 15, 20, and like that. So this is how we can get that, the multiples of 5. And similarly, if we want to get the prime number, then we can check the prime numbers in the same way as well. So for example, sysout check if number is prime. So how we will do that, we will actually check the number, we will actually loop from 1 to, actually from 2, we will start the loop from 2, and we will go up to, for example, let's say the number is 47, num equal 47. So we will go up to 40, the loop end equal to 47 divided by 2. We will loop up to the half of the number that we want to check. So we put it here like this, and then what we will do, we will check whether when we divide this number mod I equal to 0, whether it is 0. If it is 0 for any of the loop variable, for any of the loop variable value, if it comes as 0 and this condition passes, is not prime, then it means it's not a prime number, and we will break. If it's not prime, then we will print out num is not prime, and we will break it. Otherwise, we know that it is a prime number, so we can actually paint it like this, is prime equal true. So and here we can do it is prime equal false. Actually we can do it like this. So and then after the loop we can print it, if is prime, if is prime, then this number is a prime number, and if else it's not a prime number. So we can print it out like this, and let me show you that num is prime, like this, and then we run it. This is 47, we know that it's a prime number, so it should return it's a prime number. And if we do it like here, I should use the variable here. If we put 48, then it's not a prime number, it is not a prime number. So if we want to check, we want to get all of the prime numbers We can for example, we want to check multiple numbers whether they are prime or not, then we will have to have uh, nested loop, etc. And we can actually, if we want to check, we have a list of numbers and we want to check those that list, then we can actually use for method. We can take this code into a separate method for we can let me do it, refactor, and we extract it and we check is prime, and then we pass the number here, so it will print out. And then we can put another loop here, for example I equal to 2 and I is less than 20 equal to 20 I plus plus, then and we call this number for every I. So then it will print out all the prime numbers from 1 to 20. Actually it will check the status and will print out the status for every number up to 20 whether it is prime or not. So 2 is prime, 3 is prime, 4 is not prime, 5 is prime, 7 is prime, 11, 13, 17 and 19, they are all prime. So this is how this mod operator can be used, and it has a lot of application in different cases. In real life it's also useful operator, and this is all for this current tutorial. Thanks for watching it, and please subscribe to this channel, and if this video is helpful then please like it, and you can reach me out using my LinkedIn profile or email address that is also provided in the video description. Thanks, and please stay tuned for the next tutorial.